Hello, today we're going to be talking about graphing systems of linear equations. So we're going to solve them by graphing. Now this may not be the best way to do it, but it's a great way to visually see the solutions. Then we'll be talking about solving them algebraically later on. So here's our first example here. We want to graph these and we want to talk about its solution. So its solution would be where they intersect. So if you're using a TI-84, we have to get these in the slope-intercept form in order to be able to graph them. So I'm going to start off with that first equation of x plus 4y equals 5. So I got to get y by itself. I'm going to subtract x. I got 4y equals negative x plus 5. And now I need to divide everything by 4. So I get y equals negative 1/4 x plus 5/4. So then we'll be able to graph that one. Our y-intercept's at 5/4 and our slope's negative 1/4. So now we got to do the same thing for the 2x minus y equals negative 8. So I'm going to subtract 2x from both sides. And I got negative y equals negative 2x minus 8. Now I'm going to multiply everything by a negative 1 to make the y positive. I get 2x plus 8. So these are the two equations we need to graph. So hopefully, they have different slopes. They're definitely going to intersect. So what we're going to do now is switch over to our calculator, and we're going to type them in. And, you might be using Desmos or whatever you're using online is fine. So I type them in, and then we hit graph. So we can see it looks like that we have an intersection right there. I'm just going to keep tapping it. So that looks like it's at negative 3, 2. So we would say our solution's at negative 3, 2. If we wanted to verify that, we could hit second calc and go down to intersect. And then we hit enter on the first curve, enter on the second. Then the guess, we're just going to move it as close as we can to where it actually intersects. We're going to try to verify that that's negative 3, 2, which notice it tells us it's negative 3, 2. And you could do this by hand if you wanted to, but it's kind of hard to do graphing assignments online by hand, so you probably want to rely on some technology. All right, so here's our next example. So we got to do the same thing. So that first equation, I just got to subtract 2x from both sides. So I get y equals negative 2x plus 7. Now, second equation, I'm going to do a little bit more work. I'm going to start off by subtracting the x from both sides. So I have 2y equals negative x plus 2. I'm going to divide everything by 2. So I get y equals negative 1/2 x plus 1. So I'm going to graph this guy. I'm going to graph this one. So let's switch back over to our calculator. Go to y equals. Let's clear all that out. So I got negative 2x plus 7. 7 didn't work. There we go. And then negative 1/2 x. So negative x divided by 2, I don't feel like doing a fraction, plus 1. Now we're going to hit graph and see what we got. So it looks like those are intersecting at what, 1, 2, 3, 4, negative 1 maybe? Looks like 4, negative 1, but let's verify that. Let's go to second, calc, fifth option, and we're going to go first curve, second curve, and then we're going to move our cursor for the guess be as close as we can get it. And we're going to press enter. 4, negative 1. So pretty easy stuff, right? So again, the graphing is not the most effective method. It's not the most efficient, but it does give you a visual representation of them. So this also has the opportunity of creating a few different possible solutions. So in these examples here, two lines that aren't parallel will always intersect at one point. Now, number 2 there is talking about two parallel lines. So two parallel lines will never intersect, so there is no solutions. And then if you have two lines that are the same equation, that means they land right on top of each other and would have infinitely many solutions. And we'll see more of this in the next section. You guys have a great day.